Today we are going to review solving quadratic equations. Now, this is pre-calc. And last year, in ninth grade, you were asked to solve something like this, right? Now, how are you going to solve this? This is a quadratic equation. Anything to the second power is, if the degree of the problem is a 2, it's a quadratic. So at most there's 2 solutions. There could be 0, 1, or 2 solutions at most. Now, there's how many different ways to solve, what are the techniques to solve a quadratic equation? Well, some of them are simply factorable. Simply factorable is something like, this is the easiest thing I can think of for you, x squared minus 4. How does that factor? It factors to be x minus 2, x plus 2. And so your solutions are 2 and negative 2. So not all problems are simply factorable. If it is factorable, you can break it up like that. So let's review this problem right here. This is example 1. Example 1. It says solve this by factoring. Now, these are like 1 through 12 on the worksheet I passed out to you. So how are you going to factor this? See if you remember this. How do you factor this? What's the first thing you need to do? Go ahead. What do you?
Oh, subtract 10 from both sides.
Yes, you need a 0 on one side. You need to set this equal to 0. And now I'm telling you it's simply factorable. I am not teaching you how to factor or how to take the square root or how to complete the square or how to do the quadratic formula. These are the things, and there's actually another one. You can use your graphing calculator. I want you to add that. So there's 5 different ways. There's 5 calculator. There's 5 different ways that you can solve quadratics. Factoring, you could take the square root of both sides, complete the square, you can use the quadratic formula, and then there's one that you're going to learn in a few days, which is using the graphing calculator. Now, in Algebra 1, you did all of these. It took you about a month to do them. We spent about a month in ninth grade doing these. Then in Algebra 2, we spent like a day of each of these. So like about a week we spent. And now in pre-calc, we're going to review all of these in one day. That's what our goal is today, is to just review them.
Good try.
Now, why do you need to be able to do this problem? Because it's not that I'm teaching you how to factor. Some of you are thinking, didn't we already do that? Why are we doing it again? Because my job this year is to teach you how to do this problem. So I want you to see the importance. So if you can't factor this, you're not going to be able to do my trig problem. Okay?
Oh.
So how do you factor this? Can anyone tell me what to do? What times what is 3x squared? Yes.
Wait, do I do both? Just both?
Yeah, you can tell me whatever.
3x plus 5 times x minus 2.
X minus 2. Okay, she's got 3x plus 5 and x minus 2. Let's see if this works. 3x times x gives us 3x squared, and 5 times negative 2 is negative 10. But when we do the outer and the inners, they add up to be negative 1. She's correct. So then what you're going to do is set each of these equal to 0 and solve. So what's this little product equal to? Negative 5/3, and this is equal to 2. So when I teach you this problem, what you're going to have is sine x equals negative 5/3, not now, and sine x equals 2. And now, this is the new stuff. This is the pre-calc stuff that I'm gonna be teaching you. So today, all we're doing is reviewing the old stuff that you should already have down pat. If you are struggling with factoring, because a few kids, second hour, a few kids were like, I forgot how to factor. Unfortunately, you can't forget how to factor because you're gonna struggle. That's why to be in this class, there's a prerequisite of a C or above in Algebra 2 to be here. So we wanna make sure that everyone, we don't have time to reteach factoring. I'm teaching you, you want me to show you how to do this. Okay, so, does everyone have that first question down? How do you factor that? Set it equal to 0, and then do whatever method. So the first 12 problems on your homework are all simply factorable. They can be broken up. Okay, flip to the next page. There was another method, and these are like questions 13 through 24 on your homework. What method do you do when it's missing that middle term? When I say the middle term, I'm talking about this bx. If the bx value is not there, do you guys remember how to solve this one? See if you remember. Now, why do you need to know how to do this? Because I might have you do this problem. That's what we're doing. So I want you to see what's the first thing you should do. I'm pointing to it.
Divide.
Divide by what?
3.
And then what?
So you got x, yeah. Square root of 3 is x. Right?
Then what?
Square root
What answer are you gonna write?
root
Plus
3.
or minus the square root of 3.
I heard plus or minus the square root of 3. Now, read this little cautions box. When taking the square root of both sides of an equation, remember to write plus or minus on one side. On your test, if you write square root of 3,
It's wrong.
it's half wrong. You gave me half the answer. Now, what is this plus or minus root 3? Well, plus or minus root 3, square root of 3 is approximately 1.73, and the negative square root is going to be negative 1.73. So these are estimated answers. This is an estimation of this answer. These are exact. So in the directions, when it says, give me exact answers, these are exact. Estimated, plus or minus 1.7. Estimated is this answer. This is not the preferred answer, but why do you think it's nice to know these two answers? When do you need the plus or minus 1.7? Well, when you're graphing it, where is root 3 and negative root 3? Well, it's probably about right there and right there. So your graph is probably doing something like this. This would be negative root 3, and this is positive root 3. So we like the estimated answer because I don't know, even though this is negative root 3, it's about 1.7. We are more familiar with the decimal than with the radical, even though that's an exact answer. Why is this estimated? Why is it estimated? Because I'm dropping all of this. This is an irrational number. It goes on and on and on and on and on. So by saying 1.7, it's really not really 1.7. It's 1.732050808, blah, blah, blah. There's even more. Even that's estimated. Okay, just want to get that point across to you. Now, how about example 3? Do you guys remember in Algebra 2 doing these ones? You've got a quantity squared.
Yeah. Divide by 2 terms.
Yep.
Don't distribute.
Nope, don't distribute. Divide by 2. What else? What else? See if you remember this. What do you do next?
No,
You write it.
you root 2. Yeah.
And what, however you do one side, you do the other.
And.
And then what?
So x equals plus or minus root of 3 minus 4.
Okay, you should bring this over first. And then that.
Shit.
So what are these two answers? They're
Correct.
actually an estimation of the two numbers are about negative 2.3 and negative 5.7. If you converted them to a decimal. This is approximately. So these are exact. And these are estimated. Okay? Okay, the next one. I want you to turn this problem, I'm gonna change it. I want you to make this 2x squared minus 8x minus 8 equals 0. We're not gonna do that one. This is the example. Do you remember completing the square? The steps involved in completing the square?
So you move the c value over to the other side.
Okay, before we do the c value, there's a step.
Divide by 2.
Yes. You always want to make sure the a, this is the a value, it's a 1 to complete the square. So you have x squared minus 4x minus 4 equals 0. Is everyone cool with that? Now, does anyone know why you think I changed this problem around? I made this 6 and 8, and I made the 1 and 8.
You're probably going to get a better root.
What would it have been if I divided everything by 2 right here?
3.
A 3. And this would have been a 1/2. Now, completing the square and using the quadratic formula are both methods that can solve any type of quadratic formula. Completing the square is better suited when the middle term is an even number. If it's odd, then you're gonna get a fraction.
And it's better off just
And you guys are at the point now where don't do something that's more difficult. If I gave you the tools of completing the square and or quadratic formula, if I gave you this problem, I would not expect you to complete the square on this. You would be setting yourself for a lot of errors. This would be a fraction, this would be a fraction, and then you're squaring a fraction and so forth. So if you get a middle term that's odd, don't complete the square, use the quadratic formula. But that's why I wanted to practice completing the square when it's a good complete the square problem. So back to completing the square. What do you do next? After you divided everything by 2, Nick said,
take that c value.
take the c value over. Okay, then what?
And you also divide the b value by 2 and then root that out.
Cut this in half and square it.
Square it.
So what do you get when you cut this in half?
So
Negative 2 and square it, you get 4. You're going to add 4 to both sides. Then what do you do with this? Factor it, it's a perfect square trinomial. Then what?
Yeah.
Remember this?
Yeah.
What's the square root of 8?
Oh, wait, 2, 2, 2.
2 root 2.
Yeah.
And now do what with this negative 2?
3.
So what's your final answer?
X equals 2 plus or minus 2 root
Okay. Now again, these are exact. You can estimate them if they ask you to. Now, do you remember the quadratic formula?
2.
Here it is.
Negative b.
It's negative b plus or minus square root of b squared minus 4ac all over 2a.
Oh,
Now,
okay.
what do you have to do to a problem before you use the quadratic formula? Here's example
Put it
5.
into a certain.
Say it again, Nick.
Put it into
Standard
standard
form.
form.
What would standard form look like?
X is
This is all review. Now, could I complete the square on this one? This is actually better suited to complete the square, I
But-
think. I would complete the square on this one. I would take the 3, bring it over, take half of this and square it, add to both sides. To me, that's an easy one to complete the square. But they want us to use the quadratic formula. Either one's gonna gets the right answer. So what's the quadratic formula? It's negative b plus or minus the square root of b squared minus 4ac all over 2a. So 8 is your b value. What's the opposite of 8? Negative 8. Square that b value. Subtract the 4 times the a is 1, times 3, all over 2 times 1. Okay, what do I do next? What's next?
Can you make that a new 12?
Make this a 12, so negative 8 plus or minus root 64 minus 12, all over 2, then what?
You subtract. That's 52.
52. Now on your test, if you leave it like this, you're gonna get partial credit. Why? Because 52 can be broken down into what? 2 times 2 times 3, whoops,
26.
13.
Okay, I was like,
So what can you simplify 52
2 root
as?
13.
2 root 13 all over 2. Does this come back to you? Now, is this the best answer? No.
You can break that up and do negative 4
Yeah.
plus or minus 2 root 13, or, yeah, over 2, but you still have to keep that
These-
denominator 2.
So what, okay, so wait, what was your final answer, Nick?
So negative 4 plus or minus 2 root 13 over 2.
No?
It's just root 13.
I thought you had to
2,
keep that there.
you're gonna
'cause
take
it's
this
connected
2
to that.
and divide it by both of these. 2 goes into negative 8 4 times, negative 4, and these 2's cancel.
I thought you couldn't do that because it's
Nope,
attached to the root.
you bring this, you put this, you slide this under both of these. You put these, now, you could, some people do this. They'll break it up,
It's 2
they'll
different
write
fractions.
negative 8, yes. And then plus or minus 2 root 13 over 2, like that. And then you can simplify it. Some people like that way better. That's fine. Now, do you remember this word? What does that mean? If I asked you what's the discriminant of this problem, what is it?
Under the radical.
It's 52. If that number was a negative 52, that would tell us that there are no solutions.
Because you
Can't have a negative under the radical. What if it came out to be a 0?
0.
No, then that's one solution. It would be negative 8 over 2. So if the discriminant is greater than 0, which just means positive, then there's going to be 2 answers. If it's 0, there's 1, and if it's less than 0, which means negative, there are none. So let's look at this problem right here. 2x squared equals negative x minus 3. I want to know what the discriminant is and how many solutions. In other words, how many times does this thing hit the x-axis? So what do you first do?
Throw it into standard form.
Throw it into standard form. Now, the discriminant is b squared minus 4ac. The b value is 1. So it's 1 squared minus 4, a is 2, and 3 is your c value. So do the math here. What's 1 squared minus 4 times 2 times 3?
Negative 23.
Is negative 23. What does that mean?
That you're going to
That means that my
have
graph
no
is
real
going to look,
solution.
it's
Yeah.
not going to be
It's never
hitting,
gonna hit the
it's
x-axis.
never going to hit the x-axis. Let's prove it. Okay, I typed in my equation, 2x squared plus x plus 3, and now I'm going to graph it. Check it out. Is this thing hitting the x-axis? No, it is not. Okay, now, here's a couple special cases. Can you tell me what the degree of this problem is? What's the
4 to
degree?
10.
It's a 4. So, this is a quartic problem. There are up to
No.
4 solutions. But you're gonna apply the principles that we learned in factoring to solve this one. Do you guys remember how to do this? We did them in Algebra 2. Do you remember how, if it's it'll be simply factorable, by the way. So anyone think they know what the combo is? And I'll tell you this, x squared and x squared. And these have to both be minuses. Now you could try, my first instinct was to put a 2, because 2 times 2 is 4. And then I did a 3 and a 1 here. And I realized when I FOILed it, I'm not getting to 13. But then I said, well, wait, if I had a 4 here and a 3 here, that would give me 12, and then 1. So we're gonna turn that first term into a 4x squared and a 1x squared. This works, because 4x squared times 1x squared is 4x squared, 4x to the 4th, I mean. This is gonna give you negative 12x squared, minus 1x squared is negative 13x squared, and then negative 1 times negative 3 is positive 3. Do you remember what to do from here? Set each of these binomials equal to 0,
And it's all,
and do what?
it's all,
Okay, so help me out.
okay,
What do I do?
plus 1,
Add 1,
and divide by 4,
divide by 4,
and square root.
square root, what do you get?
It's equal to the root of 4. Plus or minus,
And how about this side?
plus 3, square root, plus or minus root of 3.
So there were up to 4 answers, and we got 4 real answers. 1, 2, 3, 4. If you do not put this plus or minus sign,
Only couple of
it's
answers wrong.
not correct. Okay, last one. I want to know, this is algebra here, what number would k be so that there is one solution? In other words, the discriminant, there's one answer, the discriminant has to be
Right
equal
there.
to what? Which one of these gives us one distinct?
Gotta be equal to 0.
It has to be equal to 0. So the discriminant, so we know the discriminant, the b squared minus 4ac has to equal 0. So now let's do this problem, but we know that a is 1, b is k, and c is 25. Let's plug in, use some algebra. So what did we say b is? K squared minus 4, a is 1, and c is 25. So I heard 100. What's 100?
That's 4 times 1 times 3.
Then what?
It's 10, k is 10. You
Is
add
it
100
just
to the
10?
others. Plus or minus. Yeah,
Plus or
10.
minus? Whoops.
Yeah, plus or minus. That's all.
I'm going fast. So 10 and negative 10 are your 2 solutions. Questions, anybody?